My name is Catherine Losinski, and it is August 25th, 2024. So the first script case I chose was script case number 2, muscle glycogen phosphorylase deficiency, and this is set up as a dialogue between me as a provider and a patient and their family with this deficiency. So the patient and the family would begin saying, "I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise?" Certainly. Let's start from the beginning, okay? Think of muscle glycogen as a stored form of glucose. Glucose is a type of sugar that your body gets its energy from in a form called ATP. So during normal day-to-day processes, your body receives glucose from the blood through a process called glycolysis. If your body needs extra glucose, that's when it's tapped into the stored glucose located in the liver and muscles stored in glycogen through a process called glycogenolysis. In the process of glycogenolysis in the muscle, glycogen is broken down into glucose 1-phosphate by an enzyme called glycogen phosphorylase, which you are lacking. So think of enzymes as helpers that have the ability to speed up reactions in the body. Once glucose 1-phosphate is formed, it is then converted to glucose 6-phosphate by another enzyme, which then enters a different phase called glycolysis, which ultimately makes ATP, or the energy your body needs. Then the patient and family would respond, "Okay, I think I'm beginning to understand. I really like to take long walks. Will I still be able to do this?" And I would respond, "During long walks, you should be fine. Your body prefers to use the glucose in the blood before it taps into using the glucose and glycogen before it taps into using the glucose stored in glycogen. But if you're participating in more strenuous exercise and high intensity activities such as sprinting, your body needs more energy in ATP, so it'll begin the process of glycogenolysis." The patient would respond, "That's really good to know. I really enjoy my walks with my friends, and I'm happy to see that won't be affected. But I have another question. As a result of this deficiency, will I need to get up at night to maintain my blood glucose levels?" And I would respond, "No, you shouldn't have to worry about that. You see, you have a deficiency of muscle glycogen phosphorylase. During the night, your liver is in charge of secreting small amounts of stored glucose into your blood, so you don't have to constantly be eating to keep your blood sugar in check. Your enzyme deficiency is located in the muscles, not the liver. So your liver will do all the work and you don't have to worry about it." Then the patient and family would respond, "Oh, that's great. That was a big worry of mine because I love my sleep and didn't want to disturb my sleep schedule. I have one other question. Do I need to worry about producing excessive lactate during intense anaerobic exercises?" And I would respond, "I would be cautious of intense anaerobic exercises such as HIIT workouts or heavy weightlifting. When someone participates in an anaerobic exercise such as these, lactate buildup is quite common due to the lack of oxygen one receives. See how the lactate increases in graph when the intensity of this exercise increases? So if you see on this graph, you see low intensity exercises and the lactate buildup is quite low. But once you hit to moderate/hard intensity exercises, lactate increases, and once you hit high intensity exercises such as sprinting or HIIT workouts, the lactate increases exponentially. This lack of oxygen is what causes lactate buildup in sore muscles. Also during these intense exercises, glycogen is broken down, so there's more glucose available to make ATP. Remember the energy your body uses? So I would be extra cautious during these types of activities. Due to your deficiency, your body will rely more on the glucose available in your blood. If you would like to participate in these activities, I would suggest several things. To begin, I would suggest eating more complex carbohydrates before you work out. This could be such as a piece of toast or a bowl of cereal. And this will ensure that there is plenty of glucose available in your blood to give you the needed energy. Additionally, we can look into some supplements that might be available to reduce lactate buildup, such as the amino acid beta-alanine. There have been studies that taking this amino acid can reduce lactate buildup and in turn act as a buffer in the pH of your blood. Even implementing short breaks during your workout can help your body receive more oxygen and lead to a decrease in lactate buildup. These are all great questions. Do you have any more for me? So that is the end of the script case 2 dialogue. The second script case I chose was script case number 4, which is a case of glycogen storage disease. So I believe the 2-month-old female has glycogen storage disease. According to the lab and report, the baby's blood glucose levels increase after breastfeeding, but she cannot maintain blood glucose levels within a normal range during fasting. So hypoglycemia is a symptom of glycogen storage disease because although one can maintain blood glucose while ingesting glucose. In this case, from breast milk, the glucose is depleted during fasting, leading to low blood sugar. Due to the disease, one cannot use the normal stored glycogen as a way to increase sugar in the blood. Jittery spells also accompany hypoglycemia. When the body's sugar falls, epinephrine is released, which is supposed to stimulate that glycogen breakdown. Epinephrine also stimulates that fight or flight response in our body, which can lead to feelings of being tired, anxious, sweatery, or even jittery. When the body's blood glucose falls, the body is threatened and causes these feelings as a way to protect itself or warn itself that it's in trouble. So this symptom still aligns with the glycogen storage disease. The case states that epinephrine is administered and there is no increase in blood glucose, but there is an increase in blood lactate. The release of epinephrine from the adrenal glands stimulates glucose breakdown. Due to the fact that there is no increase in blood glucose, that points to a problem in the breakdown of glycogen to glucose in the liver or the storing of glycogen. Since there is an increase in blood lactate, this could mean an increased production of pyruvate from glycolysis, which is then shunted towards a different pathway. Instead of making glucose, the pyruvate is converted into lactate by lactate dehydrogenase, which then builds up in the patient's body. An enlarged liver, or hepatomegaly, aligns with the diagnosis of glycogen storage disease because glycogen is stored in the liver, and if it cannot break down properly, the liver will continue to enlarge while storing that glycogen. The diagnosis is most likely not hereditary fructose intolerance. Breast milk is primarily composed of lactose, which is glucose and galactose. Fructose has not been introduced to the baby's diet, so it couldn't be hereditary fructose intolerance. Galactosemia is a disorder that inhibits the patient's ability to convert the galactose to glucose due to a deficiency of the enzyme galactose-1 phosphate uridyrotransferase. Although there is galactose in breast milk, this is an unlikely diagnosis because this would lead to an increase in galactose in the body, which is not reported, and main symptoms include vomiting, diarrhea, and jaundice, which is also not reported. Glucose 6 phosphate dehydrogenase deficiency is a deficiency of the glucose 6 phosphate dehydrogenase enzyme, which plays an important role in the pentose phosphate pathway. This pathway produces ribose 5 phosphate sugar, which helps build that DNA and RNA, and also produces NADPH molecules. This is an unlikely diagnosis because this condition is associated with a red blood cell breakdown, which is not apparent in this case. Its common symptoms of pale skin, jaundice, and enlarged spleen are not present. Due to these reasons, the most likely diagnosis for the patient is glycogen storage disease.